Underrepresentation of Women in Science, Technology, Engineering, and Math Fields, an intervention project by Alison French, Kenzi Stemp, and Kyle Vey for WGS 210, Spring 2014. We started our project by brainstorming a few gender-related challenges society presents regarding women in STEM fields. As a group, we took some time to reflect on these gender-related issues that came up in our daily lives and what we could do about them. Some of the challenges we noticed included that women are generally less likely to be taken seriously in STEM fields based solely upon their gender, that women are less likely to be recruited into a male-dominated industry, that women are discouraged from taking roles in the STEM fields by advertisements or stereotypes, that women are often underrepresented in STEM fields, and that women and girls in the sciences often do not have female role models at universities. The readings and lecture from the course helped us identify some of the issues we noticed and gave us the knowledge base we needed to make appropriate analytical observations. Additionally, we were able to draw on some of our personal past experiences in minority situations to help us recognize some gender-related problems. Our brainstorming allowed us to focus on a single issue that both interested all of us and would allow us to collect tangible data while interacting with members of our community. The underrepresentation of women in STEM fields is highly evident in a historical sense, and despite an increasing proportion of women entering STEM fields, they are still the minority. A bit of research into the matter showed the lack of women in STEM fields to be a well-studied and significant occurrence, and led us to develop a complete problem statement as follows. There is a very obvious disparity in the representation of men and women in STEM fields, particularly at a university undergraduate level. Although the number of women and girls in these fields have increased over the past 30 years, the underrepresentation of this group is still an important issue. Women and girls are often discouraged from pursuing educations and careers in STEM fields for a number of reasons, one being the lack of female role models to pave the way. The underrepresentation of women in STEM fields is a multifaceted and complex issue. We aimed to develop this project around one possible cause of the gender disparity seen, in this case, the lack of women in higher education. We looked at quite a few articles to learn more about the history of women in STEM fields and about the factors that may cause underrepresentation of women in these fields. A few articles specifically helped us understand the issue better and gave us some background on the topic. The first article, by Blickenstaff, cites several historical studies showing the true underrepresentation of women in STEM fields and outlines a few interesting reasons for the trend, a few of which were familiar to us. These issues include biological differences between men and women, girls' lack of academic preparation for a science major or career, girls' poor attitudes towards science and a lack of positive experiences with science in their childhoods, and cultural pressures on girls and women to conform to traditional gender roles. This article helped us tease apart the reason that women are in the minority in STEM fields and gave us some insight into the nature of science and how it can affect women's career choices. The Sonert article looked at how 4 different factors affected the percentages of women in STEM fields. These factors included 1. The percentage of faculty who are women in the students' majors in science and engineering areas, 2. The students' disciplines, 3. The type of institution in which students were enrolled, and 4. A time trend. This study helped us understand a few more of the main factors playing a role in female underrepresentation. Finally, the video lecture from Dr. Simone Peterson-Hudra was a course-assigned lecture that we think fits in well with the ideas of our project. Dr. Simone touched on several issues that were important to our project, including a lack of female role models in the history surrounding women in STEM fields. Her personal accounts and experiences resonated and helped us to better understand what it was to be a minority in her era and how important it is for us to fight for equality. After discussing several different ways our plan could be carried out, we decided a set of informational poster sessions on campus would be the best way to discuss the issue with our community. we decided to gather publicly available data from the NCSU directory to present with our poster in order to help engage our peers and to encourage other students to share their understanding of the topic. We collected data across 2 engineering fields, biomedical engineering and mechanical engineering, in order to understand differences in gender ratio between the 2 fields and to determine whether or not the female faculty and staff representation had any correlation with that of the students. The information on male to female student ratios were taken from the NCSU directory, while the data for faculty and staff members was taken from departmental websites. If an individual had a gender non-specific name, they were not counted in the investigation. Also, it is important to note that the fields of biomedical engineering and mechanical engineering were chosen as representatives of 2 ideal cases. The results we found are meant to be extrapolated to other STEM fields. In addition to learning how the public reacts to being exposed to gender-related challenges, we also hope to answer a few important investigative questions with our project. These included: 1. What are some of the underlying reasons for the difference in gender ratio between these 2 STEM fields? 2. Is there a correlation between the ratio of female to male faculty members and the ratio of female to male students? 3. Is our community interested in the subject matter and willing to learn about these challenges? And 4. What can general community members do to promote change in their own fields? Setting up our poster in the Brickyard and on Centennial placed us in direct contact with the NCSU community, and it provided a friendly and comfortable situation for people to approach us, as well as for us to reach out to them. Instead of a formal presentation or a letter to the faculty, direct conversation was a stimulating venue to engage passers-by and build a more diverse connection. Additionally, being in a public space allowed us to actively engage people that would normally ignore gender-related issues. So, in addition to those who were actively willing to learn about our project, we were also able to reach out to less motivated individuals or those that were completely unaware of the challenges we were presenting. Our implementation plan drew upon data from the NCSU community. We recorded the amount of females and males, both faculty and students, in biomedical engineering and mechanical engineering. The female-to-male ratio of students in these departments were taken from the NCSU directory. Similarly, the same data was taken regarding the faculty members from the departmental websites. We then analyzed the gathered results and created a poster to display for others to see our findings. In order to engage the community and implement change, we chose to host 2 different informational sessions, one in the Brickyard and one on Centennial campus. Students, faculty, and staff members had the opportunity to learn about the data that we collected and what they can do to make a change. Several days before our presentations, we posted flyers around campus with information regarding the times, location, and topic of the information sessions we were going to hold. Additionally, we encouraged members of the university organizations that we belong to, friends, and classmates to not only come and speak to us, but also to spread the word about our presentations. The majority of the roles for our project were shared amongst group members. We split up the work for recording and analyzing the data, designing the flyer, and creating the poster, and then all came together to present it all to the community. All 3 of us were in attendance and contributed to the presentations, and we had several group meetings throughout the duration of the project for planning purposes. This project involved the use of software programs such as Microsoft Excel and MATLAB for organizing and collecting the data, our website to present the proposal, reflections, and final presentation, Microsoft Word for the development of the flyers and posters for the event, and Microsoft PowerPoint and YouTube for the creation of this final presentation. Here are photos of the flyer and poster that we mentioned in the implementation plan. The photo on the left is of the flyer that we printed out to advertise for our informational sessions. The photo on the right is of the actual poster that we had with us during the informational sessions to display our findings for the community and draw people to our table to discuss their thoughts on the issue. This slide shows several pictures of the informational sessions that we hosted at Hunt Library on Centennial campus. Our goal with this location was to get feedback from those in STEM fields to see what they thought about women being underrepresented in their classes. We assigned one person to be the main presenter, and the other two group members to record the responses, take pictures, and then get involved in some of the questioning and discussions after the information was presented. The image on the bottom left was taken when we were presenting to two friends. Two more individuals approached us and asked to join the conversation after overhearing our initial discussion. This was a great example of some of the personal interest the NCSU community members had for this project. Not everyone that we approached, however, wanted to speak with us. We anticipated this. The following pictures are from the session that we did out in the brickyard. Kyle obtained a permit for it, and we all met out there one afternoon to talk to anyone coming in or out of the atrium or just walking by. In these pictures, Kenzi is presenting the data, Kyle is recording the conversations, and Alison is the one that took the photos. We all took part in the interactions with the people, though, and ended up getting some great opinions from the people that talked to us. These are the results gathered to present to the community at the informational sessions. The pie charts on the far left show the faculty, staff, and student distribution of the females in red and males in blue in the Mechanical Engineering Department at NC State. The pie charts on the right side show the same thing but for biomedical engineering. The bar graph on the right of the slide shows the female to male ratio of mechanical engineers in the blue and biomedical engineers in the red for the sophomore, junior, senior, and graduate classes. Data for the freshman class was not collected due to the matriculation process being required in order for those students to designate their majors. We had a number of people show interest in our study and want to talk to us about it. We asked everyone that approached us why they think women are underrepresented in STEM fields, and we received some great answers, some of which we had not thought about ourselves. Some of the responses included, due to the interest growing up, spatial difference referring to a psychological reason, the maternal role women typically have, being unable to cope with demanding amounts of work, social expectations, the way gender roles are displayed in media, as well as many other great possible explanations. After we had presented our data and findings to the community, many had asked questions for us about the issue or our presentation. One person asked if there are barriers for females to join the STEM fields or if they were just not interested in them when asked why they think women may be underrepresented. This person did not know how to answer the question because he was not aware of the issue and wanted to understand a little more before answering the question for himself. When it had been asked if adding more female faculty and advisors to those fields would help more females join the STEM fields, a student responded by asking if women were empowered, then why do they need role models to tell them what to do? This student thought that if people believe women should have more power in society, they should have the ability to join whatever field they want. In other words, we shouldn't need role models to guide us. This is a really interesting point, but it is important to keep in mind that women in higher education are not only role models to young women, but are also symbols to the success that women can have. So even if we don't need role models, there will still inevitably be women holding these positions because they are doing what they have aspired to do. We have also had a group of biology major students talk to us, and they asked if it applied to all STEM fields because they claimed to have more females in their classes than males. This led us to the idea that if we were to improve our study, we should incorporate more majors into our original data analysis.
In terms of executing our desired plan of action from our proposal, things went well. We were a bit ambitious with our timing around spring break, and as a result, we had to push some things back when we were swamped with work from school, but fortunately, we had planned some extra time into completing our project. We were easily able to move things back a week, and everything worked out. Our project was overall a success in terms of our interactions with the NC State community. On both campuses, we were impressed with the input we received as to why women are underrepresented in STEM fields and what can be done about it. Occasionally, someone brought up a point or asked us a question that had not occurred to us before. It was very enlightening, certainly to us and hopefully to the individuals we spoke to as well. The next section, discussion, will focus mainly on the results from our data collection and processing. In other words, it will highlight the information that we found and how we presented it to NCSU community members we spoke to. The following section, implications, will focus more on their reactions to this information. As previously stated, the number of male and female students in biomedical engineering and mechanical engineering were collected using the NCSU directory. The number of male and female faculty and staff members were collected from the specific departmental websites. For mechanical engineering, 10% of students were female, and 23% of faculty and staff were female. For biomedical engineering, the numbers were 32 and 41% respectively. This is what we hoped to find when we set out to perform this project. These results do not suggest that female representation of engineering students is a direct result of the female representation amongst faculty and staff. These results only suggest that there is a correlation between these variables. It is important to make this distinction. This investigation did not include causality, but this correlation is definitely present, and it warrants the need for further study. These results suggest that yes, women are underrepresented in both of these fields, both for students and faculty members. However, they also suggest that increasing female representation amongst faculty and staff is one method that could increase female enrollment in the STEM fields. Combined with other efforts, the gender disparity seen in STEM could one day be broken down. A number of really important implications of the data we found. Prospective students in mechanical engineering might be curious about the program they are considering. If they were to look at the departmental website and scroll through the list of faculty members, they might not actively count the number of men versus women. However, subconsciously, they are most likely aware that the field is dominated by men. What sort of message does this send to prospective female mechanical engineers? A bad one. One that inadvertently states they are not welcome to study mechanical engineering and that they will not succeed if they do. Although biomedical engineering doesn't have a 50-50 split amongst its faculty and staff, it's much closer than mechanical engineering. This could very easily play a huge role in the determination of whether a prospective female biomedical engineer decides to pursue that route. Thus, it is really important that females in STEM are present in positions of power in order to encourage other women to pursue similar passions. Although we could not present this information to everyone at NC State, we hope that our project had a few direct implications on the community members that we spoke to. First of all, they are now aware of this issue. Education is an important first step to making a change. Second, we challenge them to come up with their own reasons and solutions for this problem. Hopefully by doing so, we will have engaged them and interested them enough so that they will want to make a difference, either actively by doing further research and trying to enact change, or passively by encouraging their female peers to pursue STEM educations and careers when the opportunity presents itself. Finally, it is important to note that the strongest societal impact that this project has was on ourselves. We are now fairly well versed in the topic, and this project challenged us to find a way to first research an important problem relevant to women in STEM, develop a way to study it and gather more information, organize our findings, and then present it to the NC State community. Although this project may be coming to a close, we will remember what we have learned and continue to discuss this issue in the future so that we may one day see a change. I wanted to include a few possible improvements to our project. For example, one of the questions we received quite a bit was, why do you choose biomedical and mechanical engineering? Why not other fields? Again, we were limited on time. We would have loved to expand this project to many other STEM fields, but we had to be realistic. A possible improvement to our project would be to include studying other fields within STEM, such as mathematics, biology, chemistry, computer science, etc. Another improvement could include contacting the university departments directly and asking if they had data regarding the number of men and women that were present, both as students and faculty. If the departments were able to disclose that information, it might help to make the data more accurate by eliminating human input during data collection. In other words, we would eliminate the gender nonspecific name category. Finally, our last improvement would be to involve mass presentation to various groups on campus, particularly those made up of students who would be more inclined to make a difference, such as Women in Science and Engineering, and the Gay, Lesbian, Bisexual, and Transgender Community Alliance, many of whom are in STEM. The improvements listed on the previous slide could certainly be involved in the future direction of this research. Unfortunately, as our project comes to a close, it is hard to say that there will be any more direct implications of our work. However, as we mentioned before, the impact on our own lives and the community members that we spoke to was very real, and that will stay with us and hopefully with them. As female representation within STEM slowly increases, we know that we will see a day when the gender disparity in STEM fields no longer exists. It is really just a question of when that day will occur. Thank you for your time. We really appreciate you listening and watching our presentation.